This video is about the Pythagorean Theorem, and the Pythagorean Theorem deals with a right triangle. What makes this a right triangle is that there is a 90-degree angle. Now, the side opposite that 90-degree angle is called the hypotenuse. The hypotenuse is the longest side here. The other two sides we call legs, and the legs are the sides that make up this 90-degree angle. Now, the Pythagorean theorem is named after a guy called Pythagoras. Pythagoras is kind of an interesting guy. You can look him up. It's named after this mathematician from ancient Greece. However, he did not come up with the Pythagorean theorem. We just named it after him. Alright, this is the Pythagorean theorem, where if we have our sides of our right triangle here, this is the equation we're going to be using. What this says is for sides A and B, those are the legs, a squared plus b squared equals c squared, c being the hypotenuse here. So here's a right triangle, and here are the two legs. So what this is saying is if this is our side A here, this is 6 units long, so a squared would be 36. The other leg, B, which is 8 units long, we're saying b squared is 64. So a squared plus b squared equals c squared. C is 10 units long, and so this square is 100. And so you can see how 36 plus 64 is 100. And so that 100 is what c squared is. And so the square root of 100 is what c would be, which is 10. Okay, so as I said, this is the Pythagorean theorem here. Let's take a look at a couple examples here. So we have problems 7 and 8, and they're asking us to find the missing side length of each triangle. I'm going to start with problem 7 here. Both of these are right triangles. In problem 7, you'll notice that we're looking for the hypotenuse here, side C, that side opposite the right angle. So that's what we're looking for here, the C. And in the Pythagorean theorem, we're going to write this as c squared. Now, you notice that they plugged 60 in for our Pythagorean theorem, and so it's going to be a 60 squared. And the other leg we have is 32. So it's 32 squared plus 60 squared. So it's the two legs squared. We're going to add them together, and that equals c squared. So 32 squared is 1024. If you have a squared button on your calculator, you could use that, or you could just do 32 times 32. And that's what's going to give you 1024. 60 squared is 3600. These two numbers added together come out to be 4624. That's what's equal to c squared. Okay? But we want to know what just c is, right? So you'll notice here, in order to get just c, you're going to have to do the square root of c squared. That's because a square root cancels out the squared part here. And so we're going to do that on both sides. So we're going to find the square root of 4624. You might have a square root button on your calculator. Some cell phones, if you turn it sideways, you can find a square root button. Also on your Chromebook, though, if you type in square root of 4624, it will give it to you. And that comes out to be 68. Right? 68 times 68 would give you this number. So the length of the hypotenuse is 68 units. Now, in this triangle, you'll notice we're looking for a leg here. That's the b squared. Right? So in this one, the side opposite the right angle here, that's our c value, or the hypotenuse. So that's what's going to go here. This is another leg, right? These two sides make the right angle. So this is going to be our a value. So similar to this problem, you know it's set up a little bit differently since we're finding the leg. but we're going to start by squaring these numbers. So 6.2 squared comes out to be 38.44, and 8.7 squared comes out to be 75.69. So we do have some decimals here. Now, in order to solve for b, you're going to want to subtract 38.44 from both sides here. So b squared is going to be equal to the difference between these two numbers, which is 37.25. As I said before, so we're looking for just the b value. That's the length of this side, not necessarily b squared. This is what b squared equals. So we do the square root in order to cancel the square to just get b. And we do that to both sides. Now, here we're taking the square root of a decimal. In the last problem, we took the square root of a perfect square, and we got a whole number. Notice how here they have these like squiggly lines for the equal sign? That's because we're going to estimate, right? You only get whole numbers if you take the square root of a perfect square. For instance, the square root of 36 is 6. That's because 6 squared is 36. Now this is a little bit more, so I'm going to estimate it to be about 6.1. If you type it on a calculator, you'll see a whole bunch of numbers. That's because this is irrational. If it's not a perfect square, square root comes out to be irrational. You get a lot of decimal places. It goes on and on. Here I'm rounding it to the nearest tenth, or 1 decimal place. So we're going to say that this is about 6.1 inches. Okay? Now, we're going to talk about the converse of the Pythagorean theorem. And so if we have side lengths a, b, and c, and if those work for our a squared plus b squared equals c squared, then the triangle is a right triangle. For instance, here they're saying we have 8 for a, 15 for b, and 17 for c. So in our Pythagorean theorem, if we plug those numbers in, we see that we get the same number on each side, so it works. So we know that these side lengths are a right triangle. So let's try this out for this triangle here. Now this looks like a right triangle. This is what I'm trying to figure out, right? They don't give us an angle measure, right? It could be 89.9 degrees. It could be 90.1 degrees. We want to know, is this in fact a right triangle? So the legs are what make up the right angle, and the hypotenuse is that longest side there. So we're going to use our Pythagorean theorem, this equation that we've learned, to see if this is a right triangle. So we're going to have 12 squared plus 35 squared. And what I want to know is, does that equal 37 squared? Now 12 squared we know is 144. 35 squared, you might want to use a calculator, it comes out to 1,225. And will this equal 37 squared, or 1,369 there? So if we add these two numbers up, it does in fact come out to be the same. Checks out.